Okay, this is Mr. Peterson, and I'm going to be giving you examples for the problems you're doing on the review for sections 7.1 through 7.6. And this first installment is problems 1 through 9. So I've got examples here. Later on, I actually label them examples, but these aren't the problems that you're doing. They're just examples like them. At any rate, the first two problems, we're supposed to find the square roots of each number. So if you type it in your calculator, you'll get part of the answer. Square roots of 289 are 17 and negative 17. I'll explain why your calculator only gives you one of those answers. But at any rate, there's 17 times 17 gives 289. So does negative 17 times negative 17. Okay, now the logic on the next one here, you got to get a 2 to get, when you square it, you get 4. And then there's 6 decimal places, so you kind of cut that in half, 3 in each, and then put your plus or minus sign. Now, when you get to problems 3 and 4, you'll see that we have that radical sign over top of the number 16 in this first example. You see that radical sign there. And what the radical sign does is limits you to one answer at most, okay? So when you have to choose between a positive answer and a negative answer, you choose the positive. So this answer is just 4. And that's why the one above it, problem number 1, I had to do the plus or minus sign. But here, when you've got that radical sign, the one I indicated here in pink a minute ago, that radical sign chooses the positive answer. Now, if we were allowed to use imaginary numbers, number 4 would be 3i because of the negative underneath the square root. But we're not supposed to be using imaginary numbers here, so we just write no real solution. Okay, on number 5, you're going to just take the square root of both parts of it. Now, you treat them differently. This is going to be 11. But in the second part where you've got an exponent, you cut the exponent, you divide it by the index out there, and the index when it's blank is 2. So we'll get a 5th power when we're done with this thing here. The other thing is you got to make sure you got a positive answer. So you're going to put absolute values around that part, the x to the 5th. The rule for that is if your original index is even, there's a little 2 out there, and your exponent at the end is odd, then you need the bars. Okay, on example 6 here, we're going to take the cube root of 27, that's just 3, and we're also going to take the cube root of the back half. When you take the 6th power and divide it by 3, you get squared. Okay, example 7, we've got 2 cube roots, and neither one of them are perfect cubes. So you start by putting it back together again, 3 times 45, and then split it up the proper way, 27 being a perfect cube, and then you simplify the front there. Cube root of 27 is 3. On the next one, you also put it back together, but the outside numbers multiply separately from the radicands, so you get 5 times 2 on the outside, and a new radicand of 18. Then you break apart your radical. Notice that instead of 6 and 3, I use 9 and 2. That's because 9 is a perfect square. Square root of 9 is 3. You'll multiply it by the 10 eventually to get 30 on the outside. And finally, example 9, last one I'll do on this video. You're going to assume that the variables are positive, means you don't need the absolute value bars, and you're going to break this one up into a perfect cube of 8, and then times 5 to get you 40. And then the 7th power that you're seeing right here, you want as many of those x's as you can up front, and so what you do is just decrease by 1 and see if that divides by the index of 3. So 7 take away 1 would be 6. 6 divides by 3, so that's what you decide to put up there. The leftover x goes in the back. Then you do the same sort of reasoning with this 14. 14 does not divide by 3. Neither does the next one down. 13 doesn't divide by 3. But if we go down to 12, we'll have one that divides by 3, an exponent that divides by 3, and the other two y's have to go in the back. Well, all we're going to do now is simplify the front. The cube root of 8 is 2, and then the exponents get divided by 3, and the back half is part of your answer. Don't lose it. Okay, that does it for examples for problems 1 through 9.